Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mounts. I'm glad you've taken the chance to, or taking the time, it could be taking a chance, but taking the time to join us today as we look at how we can improve our process through the use of data and how we can use that data from certain types of fastening tools. And this all just continues in with the data collection that happens within the manufacturing process of Industry 4.0, the Internet of Things, and the big movement of the implementation of MES systems within the process control of the entire manufacturing process. And so we're going to look at that in today's session, but to give us a kind of a primer on where we can get this data from and how we can use it, if we look at the Japanese practice of lean manufacturing, our dashed line there is going to be our capacity, meaning that if our production values, our output are on that line, that is the best that we can be doing. And then if we see any items below that line, that's going to be considered areas of waste. Could be waste of transportation, moving something from one place to another. It could be the waste of time, again, waiting for something to arrive for the next part of the assembly process. And then so anything above the line is going to be considered a burden or something that may be overworked, whether it be machinery or materials, things like that. And the distance in between those two, or the Mura, that is where we can look at the data and see how we can move to try to get that a little bit closer to that capacity line. And we can do that through the use of data collection. Now, when, excuse me, the whole effort of being able to collect and use data from the manufacturing process is obvious. We just talked about that, is to give visibility to areas that may need attention for us to be able to improve in those particular areas. It can also give us information on how we can best make decisions in regards to how we should use our resources within the process. And by looking at the data, that can certainly steer us in the right direction where we're making correct use of the information. And that's going to help us to move to be more productive through the process. And also going to help us, obviously, try to get the best return on investment within the process and lead to a better profit for the actual goal of our manufacturing processes. So the actual benefits of the data collection as it relates to fastening within that process is we actually get the ability to record and store the torque and fastening data that happens within each assembly process. And this can be done a couple of different ways, and we'll touch on those as we look at the solution for that as it would come from the Mounts products. But these could be applied to other companies as well. But we want to try to look at areas where we can reduce waste. And again, this can be waste that deals with the principles within the lean management system, whether it's time, transportation, or any of the other areas of waste, whether it's rework of things that have already been partially manufactured. All those are key benefits for that within the data collection system. And again, this gives us the ability to look at a process that is happening, and we have data to help give us the best decision-making material that we can act on quickly. And if we have information available to us, it gives us the ability to have a faster response to critical issues to help with that process. If we approve the product, then we can also look at the best process that we have in benchmarking for the actual production within a specific fastening cell or fastening line, or we move it out to determine the actual best throughput that we can see within the actual assembly process. And this helps us to optimize and improve the process. And just a note, optimization doesn't always necessarily mean faster, but we're actually, again, staying within the optimal management of the actual assembly. So, pardon me. If we look at it from a quality control standpoint, if we have the ability to monitor our tools that are giving us data, and they give us the ability to detect and correct errors that may happen within the fastening process, this is a great way where we can help to correct problems before they become worse or move down the line and create more rework that may be needed, whether that is washer stacks that weren't put in or missing fasteners, things like that. But if we have the ability to look at the data that's happening, this can really help to minimize and deter product defects and mitigate that risk on a quality control side of the equation. So one other really big advantage of being able to gather and grab the fastening data as it relates to production records. This also then gives us the ability to have those records to be able to use at a later date for auditing type of purposes, whether that be for a customer that may require the use of or looking at the production records for a specific build or item. It can also be for an ISO type of audit where you may be needing to look and demonstrate some continuous improvement within your process there. And this can also, again, be linked to a specific product build, where you would have the time, the date, all of that requires information regarding when that part was done, what the outcome of the fastening was. And so if you have that ability, again, this can really help in looking at ways that can help to limit either any liability or any other issues that may come up regarding what has already been done within that fastening process. So when we talk about being able to capture and use data, one thing that often does not get too much attention, although we are going to be looking at a smart tool system, there are other ways that you can capture data without having the use of a DC type of tool. So one way would be to use a torque analyzer with the use of a rotary torque sensor. This type of sensor can be put within the production line, and that will be able to capture the fastening data for a specific application, whether that application is a hand type of tool like we see on the screen here, a torque screwdriver, or it could be a torque wrench. It could be an electric clutch torque screwdriver. It could also be a pneumatic screwdriver or nut runner as well. But this does give you the ability to capture and record those readings with a date time stamp for that particular item. This information can be saved within the torque analyzer, or it can be streamed out depending on which type of system that you may be looking at. But this is one way that you can capture some fastening data on applications that may not necessarily use a DC control tool or a smart torque control system. And so this is one way to do it. But we'll look at the actual DC tool that we have to offer. Again, this may be very similar to other brands that may offer similar solutions, but these are going to be either a current control type of tool that may give you the ability to actually monitor or record the torque value from a transducerized sensor that's built into the tool. This is going to give you the ability to ensure that you're getting the proper torque output that you're looking for based on the preset that you may be using. These tools obviously have multiple different presets depending on which model you may be working with. All give you the ability to monitor what happens with the tool in real time. Again, so we can help to notify the operator when there is an error, and they can go ahead and make that correction at that point. These types of tools do offer integration for line control, whether it be a PLC or if it's in communication with an MES system. That is available here. And the process for recording and storing the torque data is available as well. And we'll touch on that here in just a second as well. So what type of data are we collecting? So you're going to see the preset torque that you're looking at, what that value is. And then you're also going to see what the final torque value was given in there. You're also going to be looking at the ability to add a barcode into the data field for a specific fastening. Now, the barcodes can be used in two different ways. We can use a barcode as a way to pull up a specific preset. We can also use the barcode, as I mentioned, to put that particular barcode into the data field. So if you want to track a specific component as it goes through the different steps within the build process, we can have that barcode put into the data field, again, to make it very searchable or very easily to be searchable for that particular product. And so if we were to use this in a scenario where we would scan a barcode that we have set up to pull up a preset, then we want to scan another barcode to insert the product barcode into the data field. That would be one way that we could utilize both systems to be able to capture that. The other way would be if a particular product ID has some unique identifiers within the barcode itself. So the last 6 digits are different, and those particular items will reference back to the particular part. We can tell the system only read the first 4 digits within the barcode. We'll use that as the preset, and then the unique identifiers get stored within that barcode as well. Again, giving us the ability to track a particular part through the assembly process. We're also going to get the time and the date that a particular fastening was done. And that is basically how the file structure is set up in the data. If we were to pull this data from the controller, you would have a folder that is the year, then it would go to the month, and then the day, and then all of the fastenings that were done that day, the time that those were done. And then we're also going to have the ability to monitor the amount of turn that happens within that fastening. So we would have an angle measurement that is going to be giving us some information as well. This can be really helpful if you are seeing issues in a particular process. And for example, if we had a scenario that we did just recently have not too long ago, where we had a customer that the tool was reaching torque before the actual fastener was being seated. And so Through some testing, we were able to find out that the customer had made a change in the vendor fastener that they were using, and the fasteners that the new fasteners they were getting had some burrs that had not been removed correctly, and so those burrs were causing an increase in the torque, and so the torque was being met, but the amount of turn that was happening wasn't being met. And so we do have that ability to add angle measurement, excuse me, within the process, again, to alert if there is an error and have the operator be able to account for that and fix it right away. So there are a couple of different ways that the tools can communicate through Modbus or Open Protocol within a particular MES type of system. So all of the particular presets and a lot of the different items that we can adjust or set new parameters to, all of those have addresses that we can write to. We can read from those, and those can all be set up through the ability to use either Modbus or Open Protocol to be able to have that data either inserted into our MES system or be able to stream that out and gather that another way. Now, what do you do if you aren't in that place where you're having your system networked, you're not using any type of MES system? How can we capture the data? There is an SD card that is on the unit itself, and it will be capturing all of that data for you. So you can take that SD card periodically. You can take the contents of that, and that's going to give you all of that information if you are not going to be using some of the network options. So these tools do have the ability to communicate via our 25-pin I/O or through the Ethernet port. There's also a serial RS-232 port as well. And one other unique feature that we have with our DC tools is that they do have built-in web servers. So if this system is put onto a network, you can log directly into the tool a couple different ways. You can use either our software, and we'll take a look at that here in our demonstration portion, or you can use a web browser to log directly into the controller and look at that data or pull the communication when you are wanting to change a preset or different functions like that. So there are those abilities to be able to connect to the tool. So let's go ahead and we can jump into our demo portion of today. And so what I have is I have our controller here. It's connected to one of our transducerized systems. And what you'll see on the screen is basically the information from the controller through the use of our software. So let's go ahead and jump in to that. And so on here, what you'll see here, let me just go ahead and cancel this and move this. So with our connection up here, we just select which tool we're using, hit connect, and our correct COM port, and we are then connected. So currently right now it shows that that we are disconnected. If we look down here in the bottom, so I can go ahead and hit connect, and we're now connected. Now at this point, we can come into our settings menu. This is where we can set our different parameters for our different presets, and I'll just show you what that looks like here. So we have 15 different presets. You can go ahead and enter in what torque value you're dealing with for a particular preset that you might want. You can make those changes, and they are instantaneous. But since we're talking about monitoring today and gathering data, we can go to our monitoring tab. And in here, we can look at things like our graph this is one way that we can use to look at specific data. And this may be in an effort to handle a particular joint that may have some issues where you're seeing that fasteners are being stripped or they're not seating correctly. A number of different things that way, but we can come in and we can take a look at two different types of channels. We have our channel that deals with our torque, and then we can also select our angle as well. Sorry, I'm looking at the wrong thing here. Yep, there we go. You just can't see it the way that this is broadcast. There's a pop-up screen that comes up that allows us to select which item that is, but nevertheless, we can go ahead and hit start. And now if I run the tool, it will go ahead and generate a graph rundown for us. And so you can see here that has happened. It's also going to give us information, again, the time that it was done, what channels we are monitoring here, torque and angle. It gives us our fastening time in milliseconds. Our target torque was 2 Newton meters. Our actual final torque was 2 Newton meters. We're using at 200 RPMs. And then we have our angle that we were used. And then we have our fastening OK signal here. So if I keep doing these scenarios, you'll see that the graph may change because I put the tool in reverse. But we can go ahead and we can gather this information. This information can be saved and it can be reviewed later. So if we want to go back to our graphs at different points, we can come in and we can look at what those graphs may look like. We can come in on the screen and we can get very detailed regarding where we are within the actual process. So again, if we are seeing things that aren't looking correct within the operation, we can look to try to figure out what is happening and make a good decision with the data that we are given. Now we can also do a different type of monitoring. So this would be more representative of the information that you would get when you are streaming the data. So let me come back here to the graph. We'll stop this. And then we can go to our real time. And we can go ahead and start grabbing data here. And so again, I can go ahead and run the fasteners down and we'll be getting the data from these fastenings. And so you get data off of every event that happens unless you decide to turn off certain events. But you can see here on this row of data point number 4, there wasn't any status because the fastener didn't actually either produce an error or produce a correct torque. So you can see we have our fastening OK on these 3. And it gives us our information regarding the torque that we were looking for, the torque output that actually occurred. We have our speed. You have your angle. Depending on the type of tool that you're using, you may be able to gather information such as the prevailing torque, the seating torque, or clamp torque. That is a discussion for another day, but you would also get your fastening OK with that. Now, if we make a change to the drive direction, so if I put the tool in reverse, you'll see we get a data point. If I put it back in the forward position, we get a data point. If we do a fastening and we get an error has occurred, that is going to give us an alert. And we have our fastening no good here. And then we have our alarm set data point. So this is the kind of information that you would get streaming from the unit. You also have the ability to do some process control capabilities. So if you wanted to do a study for running like an R&R type of study, or you want to look at the CP or CPK or those types of values, you can do that as well. So if we clear this, go ahead, we can use what would be our multi-sequence process. And what that does is it allows us to be able to set either a fastening routine where we have a certain number of fastenings that we are doing in a row, or we can use it to add different presets and loosenings within one rundown. But again, that may be a topic for another discussion. But we can certainly do that here. If I come in and I'll change our preset to our multi-sequence, and what this will do is it will start gathering the data from the actual system, and it just will keep running this for a series of, I don't know if it's 15 or so fastenings. But it will then generate our bell curve, and you can do some look at the performance, again, giving you data on how the tool is reacting on a particular joint or in a particular assembly. And so this can give you that type of information as well. So with that, that's going to kind of wrap things up for us in this demonstration and presentation. And with that, I will move over to Chris and see if we have any questions regarding today's presentation. So Chris, do we have any questions?
Morning, Dave. Yeah, the first question we have is, can you explain a bit more on how angle measurement works and how it, helps detect errors in torque? And then the second part is, when you refer to the angle in the tool, is it the tool itself or is it something else?
So the last one first. So when we talk about angle in the fastening process, we're talking about the total amount of turn that happens on the fastener. Now there are right angle tools that do have an angle in those, but when we're talking about it within the fastening process, we're usually talking about the fastener and how much turn. So in one revolution, you have 360 degrees. And so one turn would be 360 degrees of angle. Excuse me. And so this could play a part within the error proofing process. So we do have the ability to set a minimum amount of turn that must be achieved for a system to recognize a good torque value. And so let's just use an example. If we have a setting at 5 Newton meters, and we know it takes 1,000 degrees to typically tighten this fastener, we can say the fastener must meet a minimum turn of, let's say, 500 degrees of rotation for it to be considered a good tightening. And we can also add a maximum amount of turn as well. Again, to detect if there's a stripping issue or if there's some type of scenario where too much turn on a fastener is going to damage something. But nevertheless, if we have a common tightening area, which is cross-threading, that is going to happen right at the very beginning of the actual process. So that fastener is going to get stuck and bind up on the threads. And that's going to happen right at the very beginning. The torque will be met because the resistance of the jam there will bring the tool up to its torque value and the tool will shut off. And the operator may go on like nothing happened if they're not paying attention. The tool torqued, but the fastener is not seated correctly because there wasn't enough angle. So I hope that that explains it.
All right, Dave, thanks. The next question we had is, what's the difference between the transducerized and a non-transducerized tool?
So a transducerized tool equates the actual current that's being generated by the tool to a specific torque value. And a transducerized system has a measuring sensor built in within the tool. And so it is using that sensor as the torque value that it's reading from. So again, a transducerized system has a sensor built into it. A current control version does not. It's again equating the amount of current draw to a specific torque.
All right, Dave. Thanks. Next question is, can this system be programmed and used for like thread tapping applications?
It could. You could use this in. There is not only a mode where we can set the system to look for a certain amount of torque, but you could also set this to um, just run to a certain amount of angle or turn. So, excuse me, we can tell the system to run for a certain amount of turn. So that could be used as a tapping application. That is this type of or that type of scenario is really helpful when installing helicoils by chance. So we can tell the system to run down to a certain degree of angle. We can have it automatically reverse back up after it's been after that angle has been completed, which makes it very easy for the helicoil type of installation. So that would be one way. The tapping can be a little taxing on it, and if you're not having the tool exactly perpendicular, that could be issues unless you have the tool on an arm. But it could be used for tapping, but more ideally used for helicoil installation.
All right, thanks, Dave. And that looks like that was it for today.
All right. I want to say thanks very much for joining us today. If you have any questions regarding any of our DC tools or our torque analyzers, feel free to reach out to our sales department or our applications team. You can reach them through our website at mountstorque.com. Thanks again and have a great day, and we'll see you next time.